Okay, welcome and happy Monday morning. And we are going to continue our review for the American Chemical Society final exam by doing questions 33 through 48. Now, this is actually normally about a 70 or 80 point exam. But this is part 3 of 4, so we are going to only end up going up to 64 questions. So it's usually broken up into 2 chunks. Up through number 40, it goes through a whole year of chemistry, and then it starts and goes through a whole year of chemistry again. So when we get to question 40, there's going to be some definite review. So that's good news for you. Okay, so what are we going to do in terms of review for these questions? All right, now number 33. This is going to be a very challenging question. This is called KSP. So we had this equilibrium constant that you guys did. Watched a video on that and went through 3 or 4 examples of how to set up that, products on the top, reactants on the bottom. This KSP is just a special variation of that called solubility product. Okay. Review the process for this. This was question 20 right here. Remember, if you have A moles of A and so on, then you leave the solids and the liquids out. Well, what a solubility product is it'll always be a solid on the left, just one solid that'll break up into aqueous ions on the right. So really, all you'll have to do is take the 2 aqueous ions, since they'll be on the right side, and there'll be nothing on the bottom. Now, this is kind of hard to see without an example, but thing is, this is actually a bonus question, and you get 3 points. It gives you a free miss on the other one, on the other questions. So keep that in mind. But also, I know you guys are all smart enough, because I'm your teacher and I know this, to know that there's really no difference between a bonus point and a regular point in terms of your grade. So every point counts. So if you can get this one right, that's going to add 3 points onto your score. One of the things that we're going to be doing is your high score of these 4 exams will replace your lowest score. So I'm going to take a look at them when they're all laid out there on the grade book, and your high score will knock out and count twice. So hey, let's make this round 3 a really good score, and I'm purposely holding the scores back, kind of treating this as a final exam, and they will all be posted later. Okay, so just keep fighting the fight and working hard, but what you should do in your notes right now, or those of you at home, you could stop and take 10 or 15 minutes and do this, and take some notes on section 17.9. Read that section, write the example problems out, and it's certainly not something that is impossible for you to do. It's just going to be a challenge. It's kind of an AP level question. AP chemistry, they do these things all the time, and way harder versions of this. Okay, so remember to review that question 20 and how to write equilibrium law expressions. All right, now for number 34. Number 34 is a molarity problem. The book reference for this is section 15.4. You also are working on a worksheet today. Some of you already submitted those. That's great. There is a worksheet that's due. There were 2 different ways of approaching that. This one is actually a little bit different and in many ways easier, because they give you the number of moles and the molarity. So you just take and rearrange this equation. See what we did here is we bring the L over and the M there. So if you find the moles, divide that by molarity, boom, home free. And 35 is also about molarity. So you can see why we wanted to get some of these concepts in. This is an important chemistry concept. So this one is all set up for you. Just plug in and solve. And you don't have to do the fancy conversions and things. One of those is coming up a little bit later here, but this is something that you can look at here. All right, now number 36 is asking a question about a pH indicator. Okay, there's just a few things you need to know about this. These are acids down here at a pH. And it actually can go below this scale. A little trivia there for you. We do that in AP all the time. You have a pH of -2, but everything within most biological systems sort of falls in this 0 to 14. And if you're down here, it's a strong acid. And if you're up here, it's a stronger base. Okay? You can really reason this problem out. And what these are is they're called indicators. And an indicator is a chemical. A lot of times they're naturally occurring plants or herbs or things that happen to change color when they go from being an acid to a base. I think litmus, kind of hard to see there, is the one that a lot of people know about. Phenolphthalein is a pretty important one that's oftentimes used. So those indicators will change colors as you go to the pH. See these over here on the right will change at a higher pH. But this is definitely one. I think of this question when I look at it as sort of an ACT question. So you kind of trying to see how clever you can be in trying to figure out one of these questions. All right. So this one we will not need a book reference, but take the time to write all this down, including a little diagram of a titration with these burettes. That would be fair game to ask what the name of these glass pieces are. So just a quick little diagram. The people in class, we're going to kind of show this device when we talk about this problem. Okay? So go ahead and write this all down, and then I'll explain it. So hit the pause. Okay, welcome back. We can see that what you have here is HBr is going to be our acid. Usually that hydrogen will define that. NaOH is going to be our base. The OH defines a base. And then we set up this little equation. It looks very much like a Boyle's law problem, except for its molarity times volume equals molarity times volume. So when you're titrating, you can write this formula out, and then we're going to be solving for the molarity of the base, which would be these two divided by the volume of the base. You can see right there. Okay? And that's just knowing what these compounds are, and I gave you a big hint there, and plugging them in. Okay? So number 38 is a very similar concept, but instead of acids and bases, you're using it to dilute a solution and make a weaker solution. So this is the concentrated solution, or think of it as initial, like from our gas laws, that would be M1V1 equals M2V2. That certainly would work in this. But you can plug in the molarity and the volumes, and in this case you're going to be solving for the molarity of the dilute solution. So 37 and 38 are very, very similar problems. Okay, 39 involves some homework again, and like I said, feel free to grab your book, get this done now. An example of how a metal reacts with an acid. What happens in that chemical equation? Okay, so that one you'll want to kind of check out on your own right there. Okay, and then question number 40 is a molarity problem, and this will be very similar to one of the even problems in your molarity worksheet. Now, you're going to turn in just a photo of that worksheet by tomorrow morning, so you will definitely have this to use on the test. That certainly is something that will be very useful to you on this problem. I'll say it's just like the one of the even numbered problems, because they all had kind of a similar format. Okay, so the one addition to this one is you're going to start with milliliters, so you'll have to have your first conversion. You need to, you'll start with the milliliters and then use this as your first conversion. Otherwise, it's going to be exactly the same as one of those even numbered problems. Okay? Now, I don't want to rush here, so we're going to stop at this point because this is a good stopping point, because like I said, this is where we have gotten through 1 year of chemistry, and then they're going to start again with number 41. So I think this is a good stopping point for our first video. All right, so just tune in on the, load up that next video right away, video number 2.